Good day, ladies and gentlemen. You are highly welcome to Shito's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you should kindly subscribe to my YouTube channel. Click on the subscribe button and hit the bell right beside the subscribe button to get the notifications of my videos anytime I drop them. By the grace of the Most High God, today we are going to be talking or discussing on the topic simultaneous equations by Cramer'S rule. This Cramer'S rule can also be called determinant method. Yes, determinant method. So the reason why it's just Cramer'S rule, that is the Cramer just used determinant method to solve the problem of simultaneous equation. Therefore, is the one that came about a method how we can use determinants to solve the problem of simultaneous equation. So not only simultaneous equation, simultaneous equation is when you have two equations, then you solve the two variables simultaneously, but it is valid for the system of linear equations. Whereas a system of linear equations is when you have more than three, when you have more than two or more like that equations. So and you have the variables to be known. So now this Cramer'S rule is always valid when you have them, and also when they have the unique unique solutions. So Cramer'S rule is always always valid to solve this problem. So if we want to talk about Cramer'S rule, so I would like to briefly say something about matrix, then determinant. Matrix, and what? And determinant. So what do you really mean by matrix? Matrix is just a rectangular array of real numbers arranged in rows and columns. Let we have a matrix to be represented by A, then we have A, B, C, D. So you can clearly see here that I use the entries here as to be represented by small letters, and I represent my matrix itself to be capital letter. So that's what I'm saying. So now this is called a matrix. You can see it is arranged in rows and columns. So here we have row, and this is the row. Look at the direction, and here this is column. See the direction. Therefore, from here we have we have how many rows? We have two. We have one here, we have one here. So here we have two rows, and here how many rows we have? We have two columns. How many columns? We have two columns. So now by looking at this one now, you can see that we have two rows and we have two columns. So there are a lot of matrices. It depends on how you arrange your matrix, understand? So it can be 3 by 3, it can be 3 by 2. Just know that this is coming as 2 times 2, understand? 2 by 2 matrix, and this is called the order of this matrix. So if you like, you can let your own matrix be 3 by 2. But if you say 3 by 2, it means you have You have 3 rows and 2 columns. So that's it. Therefore, the row is coming first and the column is coming next. So that is called the order of matrix A, or you call it size of matrix A. So now that is all about that, because that's not where we are going today. So let's talk about determinants. So now let's say we see how this A to be our matrix, understand? To get the determinant of this, determinant is represented as as this. That is, this is the absolute value of A. That is called the determinant. So now to get the determinant of this A, that is determinant A, B, C, D. To get the determinant of this will be like this. That is A multiplied by D minus B multiplied by C. So that is formula. That is A. You multiply the diagonal by themselves, because you can see this is the diagonal, that is A times D. AD, then B minus B times C. So that is how to solve determinants of what of this. I don't know, maybe you are getting what I'm saying now. So if these determinants, where we are going now, before you can apply this Cramer'S rule, understand, if your determinant of what's it called of A is not equals to 0, that is when you can move ahead, or you go ahead to solve these particular equations by Cramer'S rule. So therefore, this cannot be 0. When the determinant is not equal to 0, then we can have what? We can have this. Let's say we can have the solution, and we can have the equations, that is ax plus by equals to E, and cx plus dy equals to f. You can see that is, this equation can be written in matrix form as what? As this can be written in matrix form as you try to bring out the coefficients of the variable, that is, we have a, b, c, d. Can you see? A here is the coefficient of x here, b is the coefficient of y here, c and d, like that. Then the x, understand, the variable, we have x, y equals to, you now bring up the what? Your constant times, that is e and f. So now that is how to write the systems of linear equation in matrix form. You understand now? So now, after giving this problem to solve, you can see, so you now try to write the equation given to you in matrix form. So writing this one in matrix form, you now let your A, that is, let your A be A, B, C, D. Understand? Then the next thing is to get the determinant of this A. You make sure that the determinant of this A is not equal to 0. Understand? That is, cannot be equal to 0. After that, so what do you get? You try to get the determinant of x. Why the determinant of x is what is gotten by replacing, that is, look at this, because we want to get, this is x and this is y column, this is x column. Understand? Which are the coefficients of x from what? From the, what's it called? From the equation given. So we have, if you want to get the determinant of x now, so therefore this is the column. So you replace this column by the constant time. You have E, F, B, D. Understand? Then you get the what? You get the determinant. Understand? You get the determinant. So that is it. Yes, you got the, so this is the determinant. You get the determinant of this. I don't know, maybe you are getting what I'm saying. So this will be like this. I mean determinant. So also you get the determinant of y will be, what is y? So now you try to replace this column y by the constant term. So we have AC, understand, E, F. So now after that, so you're now going to get your x to be equals to determinant of x over what? Over determinant of A, which is equals to x. Also y to be determinants of what? Of y over A determinants. And this one also can be, if you don't want to write dx, so you can have it to be determinants of what? Determinant of x, like this, over, no, so put it like that, determinants x. So let it be like this, determinant x and determinant y. Are you getting it? So that is that. So we are now going to use this knowledge we just gathered to solve the main problem. So by solving this main problem, so we are going to have this. Let's say we have this. You try to write this in what? In matrix form. That is 1, 2, 1, 1. Then x, y equals to 3, 5. So now let's this one be what? Be A. That is 1, 1, 2, 1. Therefore, we now get the determinant of A. Determinant of A will now be 1 times 1 times 1 minus 1 times 2. So we have minus what? Minus 1 to be our value to be determinant of A. Also, you look for the what? We look for the determinant of X. Understand? We look for the determinant of X. So determinant X will be determinant, that is dx. Let's say dx. So determinant of X will be this. What is determinant of X? Now I told you that you try to replace, because the ed. So our constant term is this. We have 3, 5. The X row, you replace it by the constant term. Then what you have here? We have 1, 1. So get the determinant. We have 3 times 1 minus 1 times 5. So this will give us what? Minus 2. Are you getting it now? So now also we have what? We have to get dy. So to get dy here, so dy is going to be you replace the constant term, that is 3 over 5. You replace 1, 1, understand, with the constant term 3 over 5. 3, 5. Sorry, 3 and 5. So that is, you have 1, 2, 3, and 5. Then you get the 1 times 5 minus 3 times 2. So 5 times this, we have minus 1, because 1 times 5 is 5, and minus 3 times 2 is what? Is minus 6. So we have what? We have minus 1 to be this one now. So now to get our value of X, what do we do? Our X, that is that we are looking for, will be dx over what? Over determinant of A. So our dx from what we are given here is minus 2, and A is what? Is minus 1. Therefore, you reduce this, you have what? You have 2. So now y will be dy over what? Over A determinant. So equals to, what is our dy? Dy is what? Is minus 1, and the determinant of A is what? Is minus 1. Also, you reduce this one, so you have what? You have 1. Therefore, we have the values of X and Y respectively as X equals to what? 2, and Y equals to 1. And that is the solution to the problem. So if you have any question to ask, kindly hit on the comment box and ask your question. Also, if you don't, or if you have not subscribed to my YouTube channel, so try to do that, and hit the bell to get the notifications of my videos anytime I drop them. So you have a wonderful day and have a beautiful day ahead.